Hi everyone, my name is Maximiliano Contieri. I am from Argentina. I'm graduated and teacher on computer science on University of Buenos Aires. I've been teaching and working in the industry for about 25 years and been practicing TDD for at least 15 years. And in this talk, I'm going to show you how to practice with TDD on legacy and coupled systems. And we're also going to tear down some common myths. This talk is aimed at people with few experience on TDD. I don't know if you know the technique, so I will start with a very brief definition. This will be our agenda for the next 25 minutes. We're going to explain TDD in a few words. We are going to show a real impact on a real system. There are a lot of TDD courses and katas out there, but many of them show isolated and some very simple example and do not teach us how to insert the whole process into continuous integration, continuous deployment on a real system. And we will also show all software roles sharing the process and working together. Okay, let's go quickly by the definition. TDD is a development methodology, it's not a testing methodology. This is a common mistake. It is used for programming, not for testing. The tests are written first and the solution always has to be super simple, even if it's hard-coded. We must never anticipate under any circumstances. This allows us to avoid very complex and imaginative solutions that do not have contact with the client requirements. And it also gives us full coverage on all cases described. As you might be familiar with, this technique was created by Ken Beck in 2003, and today it is used in many parts of the world. I will explain TDD cycle. Maybe if you're here, you know about it. I assume you're familiar with the XUnit family for running automated tests. Every language has its XUnit framework to run automated tests. The first step that is requested by TDD is to add a test based solely on behavior, deferring implementation decisions such as data structures, algorithms, and so on. The step two asks us to run all the tests. The test created in the previous step should fail, and the former, of course, not. And then on step three, we need to write the simplest solution, never program more than necessary, following keys, keep it simple, and YAGNI, you're not gonna need its principles. And optionally, step four asks us to do a bit of refactor the code when it starts to stink. We should never do steps 1 and 4 at the same time. This is known as the TDD cycle. You can see it on the bubbles. Well, design benefits. Well, with TDD, we get more decoupled systems. This is more evident on large and fragile systems and not so much in small exercises. The code is more modular and easier to debug in isolation. We have more coverage. The steps are very small. We take baby steps. We avoid making premature optimizations ahead of our time. And this methodology is based on how we learn from childhood, based on examples and not based on definitions. Okay, let's start destroying some common myths on the industry and software development. TDD does not guarantee good designs. Just good designers are the ones that guarantee good designs. Okay, so let's visit what are the TDD preconditions or requirements. We need to be in full environmental control. We should not have global variables, global functions, no singletons, no configs, no databases, no caches, no external API calls, and no side effects at all. We need to be in full control of everything on our tests. TDD will help us detect coupling sources and lead us to a cleaner code and focus on solving essential problems such as business logic and encapsulating accidental and implementation problems. There's another myth, of course, we cannot do TDD and coupled systems. This is what this talk is about, and we will try to demolish this and other myths as you have seen and will see in the next slides. Okay, show me an example. Let's see a real example, enough talk. We have a COVID-19 streaming ticket reservation system for online concerts last year and this year. The user chooses her artist with regular expressions using user interface. Regular expressions have poor performance in some relational databases, and we need to avoid them as much as possible. Given our current database stack, we cannot change, sadly, our database stack. We're going to crash the myth that TDD cannot be used to improve the performance of the system. We are going to do it in this example. And our system generates this type of dynamic queries based on user inputs. If you don't know SQL, think of regular expressions or just text pieces. It's not important to know SQL for this exercise. We have 5 different conditions entered by the user on the input on the UI. Patterns in red, you can see, are redundant and yield unnecessary and costly operations to the database. They do not add value. For example, the second is represented by the third, the fifth by the fourth, and our engine is not very smart to infer or deduce these rules, but we are. We should transform into this. This example is more performant and semantically equal than the previous one, and this is the whole problem we need to solve. Let's start with TDD. The example is made in PHP. You don't need to know PHP. I think it as a pseudocode. I think it's declarative enough to follow the examples. And TDD starts the cycle by asking us to create a case. The first thing we need to do is to create a case. Neither the class nor the function that solves the problem are defined, just the test case. I'm defining a fancy light parent simplifier, you can see there, and a simplify method that don't exist yet. They are probably lousy names, no problem. We always have step 4 and good ideas to make refactors. We will always start with the simple case. In this case, I'm using a methodology called zombies that guides the order of the cases so that we do not forget any of them. This case is the empty case. 0 is the seed in the zombies, asserting that if there is nothing to simplify, nothing is simplified. This is a step 2 of the cycle. We need to write the code to pass the test we defined in the previous slide. The simplest solution, always return an empty array no matter the input. The parameters you pass to the function do not matter. Solution is hard-coded. Return an empty array. The 2 brackets you see there after the return are the PHP equivalent for an empty array. We always return an empty array. And so this is the myth. Hard coding is not a bad practice. Unless we have the crystal ball and know the algorithm for everything, that would not be TDD, would be futurology. We prefer to do TDD. Okay, let's add more examples. Step 1, we add another simple test. If there is one term, the simplification is the same term. As we run the test and it doesn't work, of course, step 2, we modify the implementation. The solution has to work for all pre-existing examples, just one case because we are starting. And here we see the test and the solution. We continue to return a hard-coded solution, sending out the input parameter instead of an empty array. With this solution, we covered the first 2 cases. Well, but we need to start complicating cases, but very gradually, baby steps. We test 2 independent expressions. To our surprise, the pre-existing code already works. What does it tell us about our solution? We return what we received. This works for 1 or n independent elements. We got ahead of ourselves with the solution. Maybe we will delete this redundant test later since it's at no value at all. For now, we are happy, we keep it, everything works. We will review it in a couple of minutes. Okay, but let's start with the funny cases. One expression really containing the other. Luckily, the tests do not pass. TDD asks us to fake it if we make it. We already fake it. Now we need to make it. We skip some TDD test for short by hard-coding some elements to get this solution. This is a possible solution for related patterns using a substrate compare function, which is a prefix comparator in PHP, and a filter for arrays. You can use similar functions in your language. The solution makes all the previous tests pass, including the last one that was with the prefix. 2 nested loops for search and searching for redundant patterns. When iterating, we see if it is included, then we remove it. It's not clean code, it doesn't matter. We don't have confidence enough to refactor yet. We are learning from the domain. However, we notice it is ugly, not very declarative, not very performant, and too complex. Myth, another myth, we shouldn't write algorithms without test cases. In this case, the algorithm has emerged based on several test cases. But the current code is ugly, highly imperative, as we said, and not declarative. So code must not be clean all the time. We will improve it once we have enough confidence. Well, most relational database engines ignore capitalization in searches. That's a configuration option. We write an explicit test that ensures this property. This probably won't work if the user changes the case from uppercase to lowercase. And this is something we have to make sure. So in this example, we changed a few letters to uppercase and run the tests. Indeed, it did not work. So we need to fix it. We tell software compare function that the comparison has to be case insensitive. This is the true parameter you can see on the fourth line, at the end of fourth line. We could have guessed from the outset, but we are following strictly a coverage map, and everything is documented in the test. Tests are living documentation. The algorithms are documented with tests. They are never documented with comments. So that's why the numbering of the test follows our learning process. So, well, the code screams for a refactor for readability. The simplified function was horrible. We're confident to refactor now because we have a battery of automated tests. I'm going to refactor without changing the test. You cannot change test and refactor at the same time. One extract method refactor, and everything is a little better and much more declarative. Use IDIs. Don't never use text editors. Refactors are your friends. All tests keep passing. The refactor, of course, since it was an automated one, worked. So let's try the real scenario. This is the requested use case, and it worked. We're done, and end of the TDD exercise. We can finish with the process. But we need to inject our solution because it was isolated. We need to simplify the collection of tests that are used on the second line. This is production code. So far, we get them directly. Now we have to simplify them. So we put our code, we inject our code between line 1 and 2. We inject the processing and simplification of the terms, and we're done with the code. Okay, commit, push, and what happened? Well, the QAs, the testers of the system, tell us that the pattern to look for could be in the middle of a word, and that was not analyzed. QAs perform the black box testing process and complement TDD job. They are not disposable. So the myth is that software development is an individual activity. QAs are sharing TDD process by contributing with cases. We are learning from the domain as we code. Requirements are not frozen. And the requirements are, since not only they are not frozen, we don't know them in depth yet. So we have to discover them. We add 3 cases that look for patterns in the middle and not just at the beginning of the terms. This test data is suggested directly by the QAs and therefore not from the music streaming domain. You can see that they are in Spanish because QAs speak Spanish. We validate the proposal with the end users to see if it complies with the business rule. Luckily, they do. Okay, we need to update the solution. We run the test failed, and we fix the code when we started using the strpos function, which is case insensitive, and also searches within a string. The previous function searched only at the beginning. We are always within our simplify. We do not change the inject code. The code from the outside does not change. And the change goes to production and goes live, and everything works. We ship it, customers are happy, end of the talk. Well, not at all. We find errors in production with sentences generated like this. This statement with an empty where clause are not valid in SQL engines. The optimizer screwed up and we didn't see it, sadly. We must correct it, but to correct code, we need to write a test. This is what TDD asked us for. The QAs help us to seed the test case. They also contribute to the TDD process. We were removing the two terms if they were the same with different case. The end user just came up with that case. We had to leave one of them representing both. We have two yes with different case, and we need to leave one because we were removing both of them. Myth, and of course, it's not just programmers who participate in TDD process. The QAs continue to contribute actively on the production technical support team. The one that gathers the production errors also does TDD with us. We do some, in order to solve it, we do some pre-processing before we start simplifying, and everything works. We do this in a private method called remove duplicates that should only be used by the simplifier internally. That's why it's private if your language supports it. Whenever we add a private method, the same question arises. Should we test it? Should we not test it? The answer, I invite you to go to that site with a lot of questions and answers so you can take your choices there. Well, solution goes again to QAs, and QAs find new bugs. The assertion expects an uppercase word, but our preprocessor normalizes it to lowercase because we were doing that kind of normalization. There are two ways to fix it. First, we can take the error as acceptable in the problem domain. And second, we can carry out a solution making the problem more complex. We don't guess or imagine answers. We involve the customer, the product owner, who accepts the first one. The client also participates in TDD and help us define the cases. But the code goes to code review, and code reviewers provide improvements validated by the end customer. Sometimes that does not have the word head, also do not have the word radio head. Could we use this emerging property? We check with the product owner and she agrees. Code reviewers also contribute to TDD. Everyone is participating in TDD. The simplifier isn't changing. We just have to change the function call and model both the positive and negative cases. No need to add tests since the simplifier is not changed. Okay, well, it worked out. Luckily, we were able to make TDD on an existing system. It was a collective and iterative process. Everyone contributed with cases. We can keep adding new cases without breaking previous ones. The solutions were simply covering the use cases, and we turned down various preconceptions of industry and software engineering. So as a future word, I leave you to read how to use test doubles to comply with the complete control of the environment by the test to decouple the system. And of course, you can start using TDD. You have seen a lot of talks in this conference. And please tell everyone to avoid the Hello World tutorials. Please change them to start, every junior should start with a self-assert false statement. You can follow me on Twitter, on my blog, where I write a lot of TDD and software design and code smells. I leave you there. And thank you very much for listening to me.